Hi guys, hope all of us are doing great. My name is Ernest and this is Ernest Sciences and Mathematics TV channel. So today we are going to look at the graphs of our trigonometric functions, and this is going to assist us, of course, visualize the aspect of the concept of the tangent of a function. So we're going to define this in terms of our periods, the domains, the notation that we can be able to give from these various graphs at the y and x intercepts respectively. Now, as we had mentioned from the trigonometric ratios, the tan of theta can be given as a ratio between the sine of or rather the tan of x can be given as a ratio between the sine of x and the cosine of x. And whenever we're going to do graphing, then therefore we're going to consider the extension of this particular function along the x and y axis respectively. So if you try to do a plot of the tan of theta for x and y functions, or rather the x and y axis, we're going to, or rather the x and y of course, the xy plane, we're going to see that they are going to have a characteristic graph, which is going to display some aspect of this specific virtual lines that we refer to as asymptotes. So these are vertical lines which are imaginary, and we're going to see them being displayed in various ranges of the value of pi for the negative and positive values respectively. So if we try to consider this one in terms of periods, a period is a stretch that is going to consist of a full circle, and therefore, sorry for that, which is going to be 360 degrees, or the value for 2 pi in terms of radians. And therefore, for the tan of theta, these specific graphs are going to be characteristic in a way, in a sense that as x tends to positive half of pi, which we can be able to see at this specific point, this is one of the functions of the tan of theta within these values of x. So as it tends towards the positive value of the pi over 2, the function is going to move towards infinity in the positive direction. And of course, this is going to be the case in the x direction, or rather in the negative y direction respectively. So these are going to define the various locations whereby we are going to see these virtual lines that we refer to as asymptotes, which are vertical lines that are going to demarcate the point between which these axes, or rather these functions, are going to tend towards infinity. So there's a range of numbers that we're going to see these graphs being confined within. So for the period, we have said that this period is going to be given as pi, so which means the stretch between this specific part and the half pi, the period is going to range between this one and this one for a full cycle, as we said. And the y-intercept is going to be basically what we refer to as 0. So in this case, we're going to see that at this particular point for pi 0, and then for a positive negative pi, this is going to be 0 respectively. This can be given in terms of a formula. For instance, if we try to look at the y-intercept, then therefore the x-intercept in this particular respect is going to have a value which are going to stretch on the positive direction and negative on these ranges of pi respectively. So this can be given as k pi, where k is an integer, which is basically a whole number that we're going to give us either 1, 2, 3, or 4. So for instance, if we try to look at the first intercept, it's going to appear as 0. So the value, if the value of k is 0, then therefore it's going to appear at this particular point. And this is pi, which is equivalent to 1. So another intercept, x-intercept, is going to appear at this particular point 1. And if the value is a negative 1, then therefore it's going to appear at negative pi, given as such. So the domain ranges of these specific graphs for the function of the tangent of x is going to range have a range of all real numbers, and then we are going to have a domain of numbers which are going to be expressed in places which are going to be given as pi over 2 plus k, where k is going to be an integer. So in any case, if we have this one being given as perhaps k equivalent to 1, this is going to be 2 pi respectively. So I've given a list of the graphs of range of numbers for the domain range, and whether this particular function can be regarded as an odd function or an even function. Now for the tangent of theta, these graphs are going to consist of odd functions, which are going to obey this specific case. Now we have talked about the concept of odd and even functions. And for the tangent of theta, we're going to see that the tangent of negative, or rather, sorry for that, I keep on using theta, but this is a value of x. So for the tan of negative x, this is going to be equivalent to a value of negative tan x. And therefore, tan x is going to be an odd function, and of course its graph is going to be symmetry with respect to this specific origin as given as such. So therefore, catch us in our other video where we're going to look at other forms of a trigonometric function, especially on the various trigonometric ratios that we had talked about, and the basic trigonometric functions for the sine, cosine, and perhaps other functions of the trigonometric ratios that we have spoken in some of our videos. So that is it for now, guys. Bye, God bless.